Hi there. Okay, as Mark says, my name's Tom Christie. I'm the author of Django REST framework, among other things. And as of June this year, I've been working on that full time. So if you or your company uses Django, I now work for you guys, you folks. Okay? I want to talk today about schemas and hypermedia. And I think that there's a huge amount of unrealized value here that we're going to be able to create once we have better tooling in place. And I want to introduce some of that and show you why I'm excited about it. In particular, dynamic client libraries, which I'm going to walk you through. So schemas and hypermedia are both ways of describing interfaces. Okay, so this is actually pretty fundamental stuff. If we're building APIs, we're building application programming interfaces. This is the way that your application expresses itself to the world. And being able to either formalize that or represent that in some concrete way is really important. We'll start with schemas. An API schema is an upfront description of the entire API. That will primarily be about exposing the different endpoints that a user can interact with for the API. For each of those endpoints, we're going to want to describe various things, such as, does this endpoint accept any parameters? If it does accept any parameters, how are they formed? Are they in the query parameters of the URL? Are they part of the URL itself? Or are they in the body of the request? We might want to describe the encodings that these endpoints accept or return, possibly status codes that they might return, and perhaps also include textual descriptions of the various different endpoints. When we have all of that in a form that is both human readable and machine readable, that allows us to build tooling on top of those schemas to take some of the work that we'd otherwise have to do in a manual way away from us and present the user with, present the developer with tooling that they can use out of the box with their API. In particular, documentation. One of the most common uses for schemas is to drive automated documentation that ingests your schema and builds you an HTML documentation, but also for things like API validation. There's various tooling for generating clients, pre-built clients, and there are starting to be some dynamic clients as well. Now, there's lots of different schema formats. I've listed various of them here, and all of those are different document formats that you as the author will write. They're just a regular file, and that's how you present the schema. Now, the first new concept that I want to introduce is Core API. And Core API, the most fundamental thing that Core API offers is an abstract model for representing schema responses or schemas or hypermedia. And this abstract model is format independent. It's a simple set of different data types that you need in order to express an API and the available endpoints on it. So as Brandon was talking about, take a simple set of data types. This is, with the document, we have a very constrained set of data types that we need in order to represent an API. Those are simply, one, the document. A document represents a resource on the network somewhere, something that has a URL that you can go to and retrieve, re-retrieve, reload, reload. We have a link. A link represents an endpoint and includes all the various bits of description that we've talked about just earlier. And finally, primitive data as well. So all of the sorts of data types that you get in JSON, you can include in a document. And a document allows you to embed both data and links inside it, and to include those in a nested fashion as well, to give structure to these abstract documents. Once we have a document, we can map that into various different schema formats. Now, what that's given us already, before we move on to any more advanced stuff, is the ability to transcode between different schema formats. We can go from an API blueprint document into the abstract document that's living in your program in memory, and then take that back down into an open API document. That allows you to then do nice things like take tooling that is built for one of the formats in particular, say Swagger UI, which is built for the open API spec, and use that together with any of the formats that we have a mapping for. The more interesting thing, however, that Core API allows us to do is to build dynamic clients. And dynamic clients, I think, are going to be hugely, hugely valuable. What they do is they take away the work that you would normally have if you wanted to build native API clients to expose to your customers or your users, and they present you with an option of not having to code that up at all, because we have a dynamic client that you can simply point your schema at and already acts as a native client in its language. These dynamic clients allow you to be working at an application interface rather than a network interface. Now, it's not like RPC where we're trying to hide the fact that these are network calls. The way that the clients are built and the way that they express themselves is very much clear when network calls are happening, but the users are working at a higher level of abstraction when they're using one of these clients. So I'm going to run through quickly about how the Core API clients are put together. Don't worry if some of this ends up not quite making sense. Hopefully, by the end, you'll have a good feel for the sorts of things that it lets you do, even if some of the details don't necessarily make sense. So the document specification is the abstract document itself. Encodings, that is a completely separate layer. The encoding layer is a description of how do you go from a document to a byte string. And there will be there may be several different codecs available with a client. Each codec will be represented with a particular content type. So that content type might be application/OpenAPI plus JSON, and that will be the codec for the OpenAPI schema that maps between the OpenAPI byte string and the abstract document. Finally, we have transports. A transport is responsible for making a network request and handling the response. And a transport needs to be able to take a link that the user has requested be accessed or interacted with, and possibly a name set of parameters, and then turn that into a network request. Mostly, what you'll be using is the HTTP transport, but transports for other network protocols are equally as possible. Hopefully we'll come to that. There's a couple of existing implementations so far. There's a Python client that you can use from within your program, and there's a command line client that you can use from the command line to inspect and interact with your APIs in a natural way. I'm going to be using loosely the pastebin example from the REST framework tutorial just as a bit of an example. It doesn't matter whether you dig it or not, but what we're looking at here is an example of a document. in a display format. You can see at the top in the green is the document itself with its title and URL. Those are fundamental properties of documents. Then the blue levels at the top are starting to represent the structure of the schema. We have the links, so each of the blue elements that have brackets, and then we have link parameters in the white, which are either mandatory or optional. So I'll walk through what happens when we make a request with one of the clients, and hopefully just the sense of how things fit together and what the underlying design of Core API looks like will start to make a bit more sense. Start off by instantiating a client and then say we'd like to fetch an initial URL. First thing that happens, inspect the scheme of the URL, HTTP. Have we got any transports registered which can handle HTTP? Yes, we have an HTTP transport. Hand over to that. The HTTP transport is responsible for taking the URI and building a request. So it goes and does that and gets back a response. That response has a content type and a bunch of content associated with it. So the transport is then responsible for inspecting the content type, seeing if there are any codecs registered that can handle that content type, and if there are, then handing it over to that codec, which decodes the content. And once the content has been decoded, in this case, let's say we have a core JSON schema. The core JSON codec will decode that byte string and return a document instance. So at that point, we have our schema document. And once we have a schema document, we can start to interact with the schema. This is the client.action method, which is the point of interaction for anything that you'll do with a document. And the arguments that you have to pass to action are a list of keys that reference a link by a lookup somewhere within that document. So we go first into snippets, then we go into list, and that's the link that we're going to interact with. Again, we'll look up the link, we'll see what is the URL on this link, what is the scheme for this URL, hand that over to the transport. The transport goes and makes the request. In this case, we will get back a plain JSON response from this endpoint. We have a regular JSON codec, not one of the schema types, but instead a codec that simply handles application/JSON and returns plain data. So whereas with the last request, we had a document object being returned to us that we can then use to interact with, in this request, we'll get back some plain data. Actions can also take named parameters. If the link includes a bunch of named parameters, then you're able to add those in to the action, and the transport is responsible for determining, based on the link and the description of the link, how to build the underlying request. There's also the command line clients. This is a quick example of what it looks like when you're using the command line client. So we've gone off and fetched a schema. In this case, we can see that it's a document that has been returned to us by the colorization, and we can see the various different points of interaction that are available to us. Once we've got that, we can then start to interact with our schema, like so. And you can see again, once we start interacting with the schema, we're getting back plain data from these responses. We'll move quickly onto Hypermedia now. So Hypermedia is a different interaction style to schemas. Whereas schemas represent this upfront description of the entire API and work in a get back a document then go and get back plain data, get back plain data, get back plain data. Hypermedia instead represents all of the data that is available at a given point to a user and all of the interactions that are available to the user in a single document, and each traversal, each interaction, returns a new document that can be interacted with. There's a bunch of different schema formats for this. The format that is built into Core API by default is Core JSON, which is a format that's been specially designed for Core API, represents either schema responses or hypermedia responses. Now, with hypermedia, there's been a lot more talk about hypermedia than is necessarily evident in the APIs that we're using. So there has been a bit of a push towards a kind of hypermedia light, which is simply this thinking of, well, when we have relationships within our API, let's express those using URLs. However, I don't think that that is really a full use of the possibilities of hypermedia. And the reason why I believe we haven't seen a transition to a fuller, more complete, more mature hypermedia style is the lack of tooling. Because if you build hypermedia APIs and you don't already have really good tooling available for it, you're just giving your end developers more work. So let's have a little bit, just a start of a look about what would this more evolved style look like. I think it's quite interesting. Whether it will end up being widely used or not, we'll see. Oh, I should step back for a moment because, of course, I say there hasn't been a lot of hypermedia APIs. Well, of course, hypermedia, every single web app that you've been using, that is the one place where hypermedia has absolutely uncategorizedly succeeded on an enormous scale because, of course, HTML is hypermedia. It's not machine browsable hypermedia, not really. It's user-driven hypermedia. So if we're going to start considering hypermedia designs that are more application-centric, we should start off by considering the application itself and think about the fundamental aspects of the application that we're building and thereby the interface that we want to present in order to use that application. So take the design of the application that you're building, strip out any of the thoughts about presentational issues or so on. Just think about the user flow, the data, the different pages or different modals or different views that might be available within your application, the data that's available within each of those, and the links that are available within each of those. And once you've done that, you can map those different pages onto abstract document types and say, what do each of our different states look like? What will each of our different states need to look like? So we'll take a quick look at using the client to interact with the Hypermedia API. Now, the initial request looks very similar to when we're interacting with a schema. The only difference we can see, well, no, I was going to say there's some data in there. There isn't any data in there, never mind. When we make our next request, however, it's slightly different. So we're interacting with the create link here, passing a couple of parameters, and a new document is being returned to us. And you can see in each of these cases that the document, in this case, the API, the snippet detail, and before that, the home page, corresponds to application pages. Now, when you build an API in this way, it ends up being quite an interesting style because you don't have this strange tension that you often do when you're building an API of, well, we have the application design and we have the API design, and they look different and they work differently. And when we're using our API on the front end, we have to stitch together these different kinds of responses and figure out which endpoints do we want to call. Does this endpoint return us all of the different properties that we're going to need, or are we going to need to go into the detail of that individual instance and pull back some more information with another request? Because it's implicit in the application interface that you're presenting exactly what is expected to be available. So you don't really have these issues that hypermedia APIs are being criticized for of being really chatty and the front end having to go off and make several different network requests in order to present a view to the user. That's not to say that you might not, in some cases, make a couple of different requests. Perhaps if you have an advanced application where it both has the main display and a different pop-up that represents some different kind of mode, that you might make individual network requests for each of those two different kinds of states. But primarily, you're presenting everything that the application will need in a given state straight to it. And once, say you're initially building for the web environment, once you've done that, moving on to then building your mobile application becomes much simpler because you already have the same, the interface that is being expressed to your application is the same as the interface that you're trying to build for your user. That's all about the client side. We can also use Core API on the server side. So there's a bunch of stuff in REST Framework 3.4 that's already gone in about automatic schema generation. There's some more stuff that's going to be coming with 3.5 as well. Briefly, how do you deal with Core API on the server side? Well, three main different options. First is don't bother. Just write your schema as a static file, serve it up from your application as a static file, so long as it's one of the different encodings that your Core API client supports, then you're good to go and you can still use Core API on the client side. Second option, return a document instance. The nice thing about that is it allows your server to perform content negotiation and to return your schema in a wide range of different formats, depending on the client's request. And finally, use some kind of auto-generation to introspect your code in some way and build the document instance that gets returned without having to write the schema explicitly. With Hypermedia, two approaches for the moment. One will be, which I believe should be available in 3.5, using the hyperlinked model serializer in Django REST framework to get that kind of hypermedia-light style of API, which isn't really focused on being application-centric, but allows you to make traversals more easily using the client and to do things like use, anyway. And the second is if you're taking this application-centric approach you're going to have to write your views explicitly because you're not in this CRUD, create, read, update, delete, data store-ish approach. Instead, everything is going to have to be done by hand. So you'll return document instances and the server will perform content negotiation to determine what format to return those to the client in. One of the nice things that is going to be coming in the next release of REST Framework is an API test client. The API test client allows you to build test cases as if you were using the core API client. And rather than making requests to the network, it will make requests to your Django WSGI application. So I've got an example here of a test case that's written with the API clients. You can see we're just putting in test server for the domain there, and everything else looks exactly the same as if we were making requests to an actual live client. And if you write tests in this way, then you're testing at the, you're actually testing at the interface level, which is how testing is supposed to be, right? You test the interface of the thing that you're building. And if you constrain yourself to not doing things like creating models on the fly or inspecting the database directly, but instead just inspecting the responses that you get back to ensure the validity and the coherence of your service, then something interesting happens. It turns out that you're writing tests that can run either locally or that you can run against your staging instance or your live instance, simply by setting a switch and saying, I would like these requests to actually go to the network instead of to the WSGI application, and by using the domain that you want those requests to actually go and hit. Oh, I should mention as well, this is built on top of a requests client that is also going to be available in 3.5. The request client gives you Python requests in your test cases and allows you to use that as your interface for interacting with your application. And rather than making network requests, goes and hits the WSGI application instead, which is a nice little tool. And again, has this property of allowing you to write tests that you can run against staging as well if you want to, for instance. I'll just have a bit of a run through of some of the more advanced things that you can do with Core API. You can load and save documents directly by using one of the codecs. We can configure the client in various different ways in order to allow us to interact with different kinds of APIs. One of the primary aspects of this is set which codecs should be available to the client. So if you have an API that is returning an API blueprint schema, then you can install an API blueprint codec and include that in your list of different content types that you would like to be able to handle. The default set of codecs has a single codec for hypermedia or schema responses, which is the core JSON codec, and 3 different data codecs: JSON, plain text, and downloads for anything else. So for instance, you can go off and make a request to an image URL and you'll get back a downloaded file. You can also configure the transports. If you wanted, that would allow you to write a transport for a different network protocol other than HTTP. More typically, what you'll want to use it for is for configuring the HTTP transport. For example, we can set some headers that we'd like to be sent on every single request. Or if we want to do something a bit more advanced, we can set a custom requests session. That lets us do all sorts of things like, well, in the Core API command line client, there's a case where we use this in order to print a debugging set of information on the request that goes out and the response that comes back by using a custom session that prints those things to the console. So you get a -- debug flag available in the client, and that's implemented using this. We can also use the configuration of the HTTP transport for setting credentials that are used with different domains. We always make sure that a credential has to be associated with a particular host name in order to ensure that you don't leak your credentials elsewhere by making a request to some media that you weren't expecting was on a different host. I mentioned briefly downloads and uploads. So In the case of downloads, when you're using the client, that will return you a temporary file instance that you can then work with. You can make uploads via the client as well. You can perform uploads either by passing a file instance or by passing a... Have I got an example of it? No, there's a shortcut that allows you to pass some content directly in code as well. Say, for instance, if you've got a CSV and you've just got that content in memory to allow you to pass that as well as a parameter. And a whole bunch of other stuff that's coming to the command line client that is kind of also available already in the Python clients. Could probably do with a bit of documentation to help users along with it, so all sorts of things. The HTTP caching will be really nice. That will be nice. Some of this stuff is still pending, so for example, the downloads that we talked about, that will be coming to the command line clients shortly. Isn't quite in there, but will be coming shortly. And the important thing about all of this is that as the tooling improves, and as it continues to improve, the value that you're going to get out of either including a schema for your API or out of building a Hypermedia API is going to increase and increase and increase. Once we have client libraries that are available for a whole wide range of programming languages, you would be missing a trick not to include a schema with your API, because suddenly you've got native clients for all these different languages, and that's hugely valuable for your end users. Documentation tooling, hopefully we'll see things like being able to present documentation to your users that is as cleanly rendered and built as, say, Stripe's API or something like that, that you can get without very much effort at all, so long as you've written your schema nicely and included your document, the textual bits of description in that schema. Hopefully, we'll start to see even more advanced tooling like API browsers. Now, I know we kind of have API browsers at the moment, but they're taking a network interface approach. So things like Postman and POR, you're building HTTP requests, you're inspecting HTTP responses. If you have this abstract interface of a document itself, you can build things that look much more like web browsers that present the actual application interface to the user and start to interact with those. If we've got things like native clients on iOS that have API browsers at that level, then we're cooking. API directories as well, so something important to note is if you're using an API, it doesn't even necessarily matter if the author of that API or the owner of that API haven't included a schema themselves, because the schema is decoupled from the API. Anybody can build a schema for an API if one does not already exist. There's a site called apis.guru, which is aiming to be the Wikipedia of APIs, so anybody can go there and add a schema description for an API that already exists. Where it will also start to get really interesting is when we start building in real-time support on other transports. I've got an exploratory branch for this. I've demonstrated what this looks like to myself, and hopefully coming in REST Framework 3.6, I'll be looking at integrating Andrew Godwin's work on channels together with Core API and giving you real-time clients that take out, well, anyway, we'll talk about that when we get there, but it should be fun. Another thing that is interesting to think about, perhaps for a future date, is there's this slight tension between the fact that the primary style within Django and many other server frameworks is this view-level style where you're taking a request and you're returning a response, and that's the primary abstraction. What would actually be quite nice is if we were writing at a level of abstraction that is all about what parameters can be passed to this action, to this endpoint, and what data is returned from it. And we push anything that is to do with taking a request and getting parameters out of it into a different layer. And that becomes quite nice because then the code that you're writing within your application more clearly represents the interface that you're actually building for your user, because you're not thinking in terms of primarily building a network level interface, you're thinking in terms of building an application level interface. Maybe this will come to REST framework sometime, maybe it will come to an entirely fresh API framework, remains to be seen. So, recommendations, schemas are a really easy win. And I would say actually thinking in terms of designing from your schema first is really helpful. Particularly if you're considering using the client library, having this upfront, okay, what do the interactions look like as your first port of call? Makes a lot of sense, especially when you can then map that into writing your test cases at that level as well. Now, as I say, I'm working on this stuff full-time now. In June, I quit my regular job, and I now have this, what I would call a collaborative investment approach to making sure that this work gets done and continues to be able to get done. I call it collaborative investment because I don't want people to think of it in terms of I'm soliciting donations. That's not about what this is. This is a whole bunch of different companies getting together and saying, you know what, this is stuff that we all use. The really, really cost-effective way for us to build this shared infrastructure is for us to each pitch in a relatively small amount, and that the return that we will get on that investment will far outweigh any return on investment that we would have been able to get from investing an equivalent amount of cash in our own internal development, because we're not just getting back the amount that we put in, we're getting back value from the amount that everybody's putting together. So I've got a kind of baseline figure for this, which is I think that the company needs to be pulling in at least 48,000 revenue a year. That's not salary, that's revenue. We're at 95% of that. If I can hit 100% of that, then I'm going to be able to commit to saying, right, I can do this full-time indefinitely. Hopefully the figure will still rise above that, and then we can start to think about doing interesting things like upping the bus factor and perhaps pulling in external contractors for implementing one of the client libraries in a particular language, other things like that. These are all the people who are currently involved in collaborating with us, because it is collaboration, that's what the investment means. And your company should be on this list. If you haven't yet considered it, please think about making the pitch to your business owner. If you would like some help with that, you're not sure about how to go about approaching them, or you want some more specifics on the roadmap, both for REST framework and for core API, or specifics on the funding, and anything like that, please get in touch with me, because, well, I want to have you on my great big list of people to keep nudging, because this is so important. And there we go. Thank you very much.
Thank you very much to Tom. We'll just have a quick handover to the